Hi friends, welcome to my YouTube channel. In this video, we are going to be calculating the H-pi model parameters using H parameters. We have already discussed about the calculation of RB-E using H parameters. I have posted the corresponding link in my description box. You please go through those. Thank you. Now we are jump towards calculating the corresponding base spreading resistance using H-pi model using H parameters. Let RB be dash is the base spreading resistance. We are calculating this one by using the H parameters. So here also, in order to calculate this one, we are taking the output is going to be short circuited. Nothing but VCE is going to be considered as 0. Then the modified circuit is going to be appear as it is going to be having the corresponding components as like this. And connecting the output is going to be get short circuited. Nothing but VCE is going to be 0 over here. This is the RCE, this is the RB dash E, this GMVB dash E, this is the RB dash C, this is the RBB dash, and the voltage here is the VB dash E, this is the VBE, and current flowing in the circuitry is IB. Now, as we have already discussed that the IB is going to be start flowing in the two branches on either side as RB dash E as well as the RB dash C, but the RB dash C value is much greater than the RB dash E. So most of the current is going to be flow through the RB dash E only. IB flow through RB dash E only. So now we come to know that the corresponding IB is going to be flow through the RB dash E and the RBB dash. So this is going to be both are in a series in nature. Now apply the KVL in the loop 1 to find the VBE. So apply KVL to find VBE. So we can write the VBE is equal to IB into RBB dash plus RB dash E. Now from this one, take the IB towards the left side, as we have already come to know that we have to keep the H-pi model and H parameters on one side and the remaining input variables on the another side. So just move the IB towards the left side. So VBE by IB is equal to RBB dash plus RB dash E. Now in order to solve further, we are going to be verifying the numerator of the left side equation is the VBE. So in order to solve this one, we are taking the H parameter equation 1. H parameter equation 1 represents the VBE is equal to HIE-IB plus HRE-VCE, and making the VCE equal to 0 as per our previous discussion. Make VCE equal to 0, then we get VBE is equal to HIE-IB. So that further we write VBE by IB is equal to HIE. Now replace the same in the above equation over here. Then HIE equal to, we get HIE equal to RBB dash plus RB dash E, so that RBB dash equal to HIE minus RB dash E. So this is the base splitting resistance calculation using the low frequency parameters, and we can write the conductive component of this one as GBB dash equal to 1 by RBB dash equal to 1 by HIE minus RB dash E. Thank you. And the remaining components are going to be discussed in the upcoming videos. The respective video as given in the description box. Thank you.